let's go over what's new. Um, First of all, I'm going to move to a different shader. Not that one. This one. This shader is supposed to be sampling a block of memory on the master memory where I'm going to store different colored pixels for uniform values. And this is a 8x8 region. And so this little square looks like that might just be, like if I duplicate this square 8 times, I think it will fill this. I should put that into MS Paint, see if that works. But this looks about the right size for a pixel. But this big green chunk here, this doesn't look right. This looks like something's wrong with this shader. So I need to figure out, are these a whole bunch of green pixels being sampled? Or is this like the sampler is somehow getting stretched, right? And I'm only accurately sampling this first point, and then maybe I'm only sampling these 4 points, and then the others are just like getting stretched across the screen. Like, I'm not sure what's happening. In order to kind of figure out what's happening, I added a little bit more logic to. I put breakpoints to places I've changed. But I've added debug fill pattern, flood fill, and checker outline. And if it's the master memory, I'm going to try to use this debug fill pattern, flood fill, and then also put an outline around the region as well. This is not really a checkered outline yet. It's just like a solid gray outline. And then this is like the flood fill is like a bluish color, like a muddy blue, a muddy, maybe a muddy pastel, maybe. But anyways, I'm not seeing anything that indicates that I am seeing that in the screen here. When I added that code for these flood fill regions, this pattern that I saw on the screen did not change. So let's scroll all the way to the top and go through all the changes in the order that we see them. Alright, so we got the, I think I already told you about this, global configuration, which is all primitives. You might want to make a note there. It is data, but your global data, your global functions, your global classes, and then your, let's see, extra initialization for other things that need to be set up that require that these exist. Let's keep on going down. Your animation loop, right? Request animation frame, and this is recursive. Well, not kind of recursive, but not quite. It's right, because if it was totally recursive, you'd blow up your stack. So it's not really recursive in that sense, but it's self-calling. Let's call it that. Okay. Init global configuration. So the master memory is 4 times as wide and as tall as the isolated memory. So I was messing around with this region right here. I guess I didn't mark it, well, I already changed it back to 8x8 to see if I could sample this region. But these are the bounds. These bounds and these constants are going to be used in the shader code, and they are already, to set up a sampling region on the master memory. And that's where we're going to like store uniforms. And this is going to be a set of uniforms indexed by the value 0, 0, 1. So eventually I might need another group of uniforms somewhere else on the texture, and then I'll make a TAU underscore 0, 0, 2 with an XY bounds as well. Let's keep on scrolling down. Uniform enums. Okay, so this is the one uniform enum I actually want. It's the index of a shader, and I want like I want editor 1, and this is a sub editor, so this is subordinate to editor all. I want editor 1 to just be a shader sampler where I have like 10 slots for 10 different shaders, and I can just select between them and just see what they look like. So I want to set the number 1 initially. Well, not the number 1, sorry. This is the location, the index location of the value dex underscore sha, which stands for index of shader. Let's keep on going. So keyboard stuff. So bit masks for what kind of keyboard event you have, the main type and the subtype. Your hot swapping rectangles. Let's keep on going. Some bounds checking. I'm not sure if I mentioned that before. All right, your global data initialization. All right, your global functions, your global classes, and this I totally changed a lot. So within this inlined object, well, first of all, you'll notice that the global classes variable inside here has the var keyword removed from it, which means that this is now referencing the global variable of the same name. And I did that so that when I initialize the editor, the editor all right here, you'll notice that editor all is null right here. However, the other editors have been initialized within the declaration for the object. And the reason I did that was, well, anything that needs to reference other objects of the global classes container, I made the initialization outside of the container declaration. So new editor all is outside of here because the new editor all constructor references global classes object so that the editor all can grab references to these editors 1 through 9. And I'm just giving the editors numbers rather than trying to come up with a fancy name. I'm just going to basically give them serial numbers, and I'll decide what the meanings for these different editors are. I think 9 different editors will be enough. Remember that this game is going to be very editor-centric, so one of these editors will actually be active during gameplay, right? It'll be an editor really that's just used for display. Yeah, let's see, where else are we? So this is just a null check, but it's named already set so that we can kind of declare which things have already been set in the object, and it just null checks this and then passes it back. So I'm just assigning the variable to itself, but filtering it through a null check, just a check for mistakes. Let's keep on going. So our adapter graphics, nothing has changed in here. Well, maybe not. Just make sure. I believe I went over this last time, but these different uniforms that are now in there. Let's keep going. Okay, so I changed this comment to 2048 because that is the span of the master memory, which I initially got wrong and was using like 10,024, I believe. Let's keep going. Let's see, right here, change the comment to 2048 by 2048, so these comments are correct now. Down here, same thing, change this comment to 2048. And then down here, actually, all of this right here is new. I added the constants for different things in the global configuration into the shader. And the way I injected them was, I exited my shader string, and then I just, define, and then added the configuration value, define, added the configuration value, right? So if I change the value of the configuration values in my JavaScript, it'll also change in the shader because of the way I've done this, right? So, and I'm using the exact same variable names, so it'll be easy to associate values in the shader with the values in the JavaScript. Like, the associations will be easy. There's no need to use different names in the shader versus the JavaScript. That's just going to make it harder to understand the connections. I also made a define for the width and height of this memory subregion, right? Just by within a macro, subtracting the x coordinates and adding 1, and subtracting the y coordinates and adding 1. Then here is the first uniform that is encoded into the texture that I want to kind of try out, and I still haven't figured that out yet because I first have to get visual confirmation that my texture sampler that samples this memory region, this memory subregion, is correct. And so far I don't think it is. So this is modulus for unsigned integer 32. This is modulus for a signed integer 32. It basically is just there's other ways you can do it, but I just wanted to be safe and just do this modulus by just using casts, right? Cast it to float, then use the built-in modulus, then cast it back. Technically, integer division should truncate, so you probably could use the formula of, what is it, like x minus y times x divided by y? It's something like that, but I didn't want to use the modulus formula that OpenGL implements for the mod function because I was unsure of the results of division when using integers. So just absolutely to make sure that it's correct, I did it this way, even though it may be less efficient, and I can look into that later. So this is a sampler for the memory subregion on the master memory, and it is going to use a two-dimensional position, and this is tx and ty, which you can think of tile x and tile y, or pixel x and pixel y, that is within this region. And these are supposed to be global coordinates, so they are global in terms of the master memory region, but they are local to this memory region. However, the distinction between global and local really doesn't matter because since I'm using inclusive rectangles, the sub-selection rectangle doesn't actually use a different coordinate system, and that's kind of one of the other benefits of inclusive rectangles. I don't have to keep on doing global to local conversions all of the time. To me, it just seems more straightforward. So we have our output RGB. To get a UV, we're going to take the tile X, tile Y, and we're going to add 0.5 to get pixel centers, because that's kind of how samplers work. So then I want to make sure that we are inside of the bounds of the subselection, and we are in the bounds of the master memory. And if that is the case... Oh, and that's interesting. So I actually see a slot of green here, and... that was supposed to be for, showing me errors. But basically, if everything is okay, so if we are totally in bounds, we're going to do the sample. And if we are not within bounds, depending on how we are out of bounds, we do different things. So for instance, if you're out of bounds on both the subselection and the master memory texture region, we're going to give red. And then if you're out of bounds on the subselection, we're going to get some green. And so, let's see, RGBA. I'm going to put the green to 128 really quick, because I'm just going to guess that if I see that green get darker when I refresh. So let's take a look at this. So we're going to change into shader mode. We're going to look at that shader. No, I don't really think I saw a difference. Let's RGB. Let's change it to like 64. Let's make it a lot darker. Let's make it like 32. Okay. So now let's refresh. Okay, let's go. So I'm looking to see if that green region gets like really dark. Okay, so that does not look like anything is happening to me. So I'm gonna guess that that is okay. The other thing I could do is, while I'm at it, I'm gonna change the out of bounds blue. I'm going to change the out-of-bounds blue and the out-of-bounds red to also very dark colors, right? That way, in case, like, for whatever reason I'm mixing up my red, green, and blue, I will still see some type of difference if I'm actually looking at that out-of-bounds memory region. So let's refresh this, And we're going to go over, we're going to look at that. So no, nope, it does not look like that is the case. Most likely, we are in bounds. In fact, I can probably, I think I've looked at this before, but let's look at it. Let's comment this out. All right, not that one, because that's out of bounds, but the inbounds. So this is inbounds, so we can write, within the bounds of everything, right? So if you're within the bounds of everything, let's comment that out, and I believe I get all white if I do that. Okay, so now if I do that, I refresh. We're gonna go back to that shader now. Okay, I get white. I get complete white when I go back to that shader, so yes. We are within bounds when we are doing the sampling, so it's not the... so I don't think it's this sampler, like the sampler, the XY sampler. I don't think that's wrong. I think that is correct. We also have another sampler that it also samples from this texture sub-region on the master memory. However, it uses an index location, and this index location is going to be that constant value that we're using to map the different uniform locations to, which are, the uniform locations are abstracted as a index within that pixel subregion. So there's the possibility that maybe this is wrong. So we have a local X and a local Y. So, you know, there's the possibility that maybe the modulus is wrong, right? And if the modulus was wrong, then these formulas would not be correct. So I could try to look at that. I know I've gotten weird results with trying to roll my own modulus, so maybe that is incorrect. That is definitely a... we're just going to make a note. Are we sure modulo is correct? Okay. I'm going to make a note there because I think that could possibly be an offender. I don't know how long I've been going, but I'm going to, oh, cool, I have a thing that tells me how long. I didn't notice that. Okay, so, I don't know, that might be where things are going wrong. I'm fairly confident in the formula because I use a shortcut for the formula, and so the shortcut has never failed me because I use it all over the place. Also, local X, local Y, and we're adding the upper left-hand corner of the memory region to get these into global coordinates, or coordinates that are both relative to the memory subregion and the master memory. So I think that this all looks good. It's just that maybe the local X, local Y formula is incorrect. Let's keep on going. Texel fetch, isolated memory. Right, so we're just going to get... so it's pretty similar to some of the code over here, right? We're just taking a tile X, tile Y value and sampling. Okay, then we have the Texel fetch, the isolated memory, but ROT for rotated. So this samples XY coordinate on the texture, but what it hands back is this coordinate rotated around the center of the texture based on the oh god, you can't see, oh god, I wasn't showing any of that. So Texel fetch isolated memory is going to sample X and Y coordinate on a texture, but it's going to rotate based on the game time. And let's go back up here for a second because I didn't. So Texel fetch isolated memory, and then right, so this is where I was saying LX, LY. If the modulus is not correct, then that might be a situation where there's a problem. The TX and TY making the LX and LY into coordinates that are relative to the memory subregion and also the master memory. This, I'm fairly confident, is correct. This function here is probably correct as well, because it's based off of the same kind of logic that's in this Texel fetch isolated memory. So I know I've made these samplers work with X and Y coordinates before, but I've had weird results using modulus and other shaders integer modulus specifically, so that's why I think this mod I32 might be incorrect, even though, you know, this modulus looks relatively straightforward, but I might want to... Yeah, actually, this very well could be wrong, because we're gonna... Yeah, I would have to see how modulus with float values works, but yeah, I feel that it could be a problem with the modulus, even though I'm pretty sure that's straightforward. I posted my answer with these formulas on Stack Overflow, so maybe someone will come and tell me how incorrect I am with that answer, and that'll also help me find the bug in my code. So I'll take the good with the bad. Let's see, we're at 20 minutes. Now let's not go over 30. Let's keep on going. Okay. Right, injecting shader code for different editor modes. So right now I'm using editor 1. Editor 0 is just going to be editor all. So there will be like a default shader mode for editor all, which will usually just be a placeholder shader, since editor all, it's really its only job is to route commands to the other sub-editors. Let's keep on going. Let's see. Are we still in editor? No, we're not in. Okay. Okay, so this is where we're creating the canvas. So this is like a setup code. We are in the adapter, the graphics adapter setup. So, oh god, this 512, this needs to be unhard coded. I'm just gonna make a note, obnoxious little note over here. Unhard code this, right? And the cool thing about having a very strict column limit is for things that really need attention, I can just put them past the column limit, and then I can just scroll up and down and find the offending regions really quick. Alright, so creating our shader, so just building our basic quad that we display the graphics on, our triangle code with our different colors. Alright, still kind of setup code, more setup code, more setup code, okay, and then the first time we draw, this is the drawing that's not inside the loop. So you'll only see this if you pause before the first iteration of the game loop. Let's go. Okay, so I did change this around. So the loop where we fill, this loop is where we fill with a debug pattern, I think, yeah? Oh wait, no, this first loop is doing an integrity check on these two memories. So I got the isolated memory and the master memory, and we're just doing a loop for an integrity check. That has not changed. But then here, this other loop where we go through those different pixel containers called unipix. That's the type within here, right? Unipix, and then data array I, and there's two in there. There's master memory and isolated memory. This loop right here is what fills them with the debug pattern. So I have extracted the old debug pattern, and I've put it in this function. So, and I've named it debug fill pattern pyramid. And then right now, if the name of the uniform pixels container is master memory, then we are going to do a flood fill specifically over the subregion of the master memory that's supposed to be encoding our uniforms. And so that's why I'm using these values. This is these four values define that rectangular subregion of master memory where I want those encoded. We'll do a flood fill on it first, and then we'll do a checker outline on that same memory region, and we want to see if we can locate those colors in the shader, right? So we want to use some shader code to try to locate this pattern to make sure that our samplers that sample from this memory region are using the correct coordinates. And so far, it does not look like that is the case, because the shader I have set up here, all it's supposed to do is display that subregion to the screen, and just stretch it onto the screen, so that way I can inspect that memory region visually, right? If I can't even write code to properly inspect that memory region visually, then how can I even reliably use that region of memory? Because it sounds like all my math for like writing the values there might be improper, right? The math for, if I can get this shader to work with that debug fill pattern, that it means that the logic for writing values to the texture and the logic for reading values to the texture are both correct. And right now, one of them is screwed up. I'm pretty sure it's the reading portion, because the writing portion is pretty basic, pretty simple. If we have isolated memory, we have do nothing. We're not gonna do any extra special patterns, right? So first we fill the whole thing with that debug pattern, and then if we want like any extra stuff, we'll do it afterwards. So that way we always have some type of data in there to look at, some type of feedback, right? Okay, so let's keep on going. So this has not changed. Okay, so right, our debug fill pattern, flood fill, right? We got the pixel container, the top left, the bottom right. Just checking to make sure that the value is not negative and not nan, and so far that looks okay. A pattern, a color to fill with, and then I created a put pixel function, but I used, so I would call this procedural OOP, right? So this is, it's going to be a function for the uniform pixels container, and the function name is putPixXY, right? And with object orientation, when you're using an object orientation pattern like C, or a language that doesn't have built-in object orientation, the first parameter is the object that it's the target of, and that's why I have unipix in here and then unipix is here, to just let me know kind of like what this function means. And so the color to set, and then the XY coordinate for where to set that color. So debug fill pattern, checker outline, you can take the pixel, and going to take the memory region, right? So once again, the top left and the bottom right. Check for invalid. Okay, 28 minutes, I'm going to stop.